Welcome. So in this part of the lesson, what we're going to be doing is combining what we know about intersecting lines and parabolas with our knowledge of the discriminant and kind of bringing them together. Let's begin by reading this bit of an introduction here. This says, when we're given a linear equation with an unknown value, we need to apply our knowledge of the discriminant after substitution. So we first substitute and the number of solutions in order to solve. When the linear line is tangent to the parabola, this means there is only one intersection point and the discriminant of the new equation must equal to 0. So what we're going to see is that when we're given a linear rule in which we have an unknown value, you first apply the substitution and then you use the discriminant to figure out how many intersection points you have. So looking here, if I have 2 intersection points, that means my discriminant is going to be greater than 0. So this is working in the same way in which when you had a quadratic and you wanted to find how many times it intersected the x-axis, if the discriminant was greater than 0, it means that it intersects the x-axis twice. Well, if you now apply this logic to an intersecting line and parabola, the same holds. If you've only got one point of intersection, that means the discriminant is equal to 0, and this is what you call a tangent line because it only touches it once. And then finally, if there's no points of intersection, that means the discriminant is less than 0. All of this may seem a bit abstract at the moment, but once we delve into this example here, hopefully things make a bit more sense. So let's give this a read and give it a go. It says, for what values of m is the line y equals mx plus 5 and y equals 4 minus x squared tangent to each other, intersect twice, or never intersect? So as we're told up here, the first thing that we want to do is substitution. We first want to do the substitution step. So that means if I know that y is equal to mx plus 5, I'm going to substitute that into my y spot over here. So I'm going to get mx plus 5 is equal to 4 minus x squared. I now am going to rearrange this so I have a normal quadratic. I don't like having my x squared term be negative, so I'm going to bring that over to the other side. Then I've got plus mx. And then I'm going to have to minus 4 to both sides to get rid of the 4 over here. So it's going to be plus 1 is equal to 0. Once I've got this, now I can apply my knowledge of the discriminant. So remember, this is going to be a, so 1 in this case. My b value, it will be my coefficient of x, and then my c value will be my constant here. So I'm using my knowledge of the discriminant now, and this is going to help me figure out what the value of m is going to be if it's tangent, intersects twice, or never intersects. Okay, here it is. Let's just keep filling this out. So my discriminant is going to be equal to b squared is going to be m squared minus 4. Then I've got a 1 and I've got a 1. So my discriminant is going to be m squared minus 4. Once I've done that, I now am going to figure out when it's tangent to each other, never intersects, or tangent to each other, intersects twice, or never intersects. All right, let's give it a go. Let's begin with number 1, which is tangent. If it's tangent, what that means is that it intersects once, so my discriminant will be equal to 0. All right, so I'm going to come here and I'm going to say m squared minus 4 is equal to 0. And now I want to solve this for x. There's a couple of different ways you could do this. One way would be to bring this over to the other side. Then you could square both sides and get it like that. So that means when m is equal to plus or minus 2, I'm only ever going to have one solution. So only going to intersect once when m is equal to plus or minus 2. The other way you could do this is recognize that this is difference of perfect squares. So I could write this as m minus 2, m plus 2 is equal to 0, m is equal to 2, or negative 2. Either way is good. As you see, you get the same answer. So using perfect squares or doing it that other way, both are good. All right, next. Someone outside of my house is doing a lot of gardening right now. All right, let's keep on going. We want to figure out when it intersects twice. All right, so intersect twice. That means my discriminant is greater than 0. So I take my discriminant, m squared minus 4, it's greater than 0. And now, remember, when you're in this situation and you're trying to solve a quadratic inequality, what must you do? You must sketch quad inequality. So I'm going to give this a quick sketch to figure out what's going on. I'll draw this, like that. Remember, I know my intersection points from up here. They're going to be -2 and 2. It's going to be this. -2 and 2. Also important to recognize here that this is my discriminant and this is my m. Because the line I've just drawn here, this line is the discriminant is equal to m squared minus 4. That's what I've just drawn. If I want to figure out where this thing is greater than 0, it's going to be here and here. Which means my answer is going to be m is less than -2 or m is greater than 2. And that's going to be my answer for it intersects twice. There it is. And there it is. I should also highlight that and put a box around them. I wonder if you can hear this person out there who sounds like they're mowing the lawn very loudly with a chainsaw. What is he doing? Oh, it's a whippersnipper. All right, let's keep on going here. The last one, so intersect twice. The last one was never intersect. Now, hopefully you can see that I actually don't have to redraw my sketch. Intersect. That's when my discriminant is less than 0. So I'm going to take my discriminant, -4. It's less than 0 in this time. Now, we could just take what we've done up here, Control C. Obviously, you're going to have to redraw this. Paste it. Take it. Put it down here. And now, we don't want the bit above the x-axis. We want the bit below the x-axis. I want this part now. So that means my answer is going to be -2 is that. That is my answer there. So when it's between -2 and 2, that is my answer. All right, so we have just answered this question. For what values of m is the line this and this tangent to each other, intersect twice, or never intersect? I want to show you what this means in Desmos now, because what I've said is that when m is equal to +or-2, it's tangent. When it's less than -2 or greater than 2, it has multiple intersection points, it intersects twice, and if it never intersects, it's between -2 and 2. Let's now get Desmos and kind of show this to you. So we're going to come here, and what I've drawn here is mx plus 5, so that's the line of the straight line. Then I've got 4 minus x squared. As you can see, I can change the value of m here. So I'm changing the value of m. So we were told, based on our working out, that if m is equal to -2 or +2, so if I go to +2 here, there it is. Do you see how it intersects once? Just there. Or if I went to -2, it intersects once there as well. So if it's equal to -2 or +2, it just intersects once. If it's anywhere between -2 and +2, so let's say it is 1, it doesn't intersect at all. So this was when my discriminant was less than 0. It doesn't touch it. But as soon as my discriminant is less than -2, it starts touching it twice, or greater than 2, it starts touching it twice as well. So this is where Desmos becomes very useful in helping us visualize what's happening here. So regardless of how big this becomes, as you can see, it's always going to touch it twice. Then over there, if it's very small, it's touching it twice still. All right. Hopefully this has made sense to you. Hopefully that's all good. Make sure to reach out if you're having troubles with anything, and I shall see you later.